All right, let's talk about object-oriented analysis and design. Now, I know, it's a bit of a mouthful, but it's actually a super powerful way to think about building software. Let's break it down.
So let's just jump right in with a question that I'm sure keeps a lot of us up at night. Why is it so incredibly difficult to build software that can actually adapt to change? Without the whole thing collapsing the second a new feature request comes in.
Well, it turns out there's a name for this. It's because software development is often what they call a wicked problem. And that's just a fancy way of saying you only really, truly understand the requirements after you've already built the solution. It's a classic catch-22, right? You're building the thing to understand the thing you're supposed to be building.
So how in the world do we manage that kind of complexity? This is where an object-oriented approach really starts to shine. It helps us kind of model the real world in our code. And the very first step is to draw a clear line between two really important activities, analysis and design.
And this slide really gets to the core of it. Think of it like this. Analysis is all about the what. What does the system need to do? What are the key pieces of the puzzle? You're basically a detective, figuring out the problem space. Then, once you've got a handle on that, you switch hats. Design is all about the how. Okay, how are we going to build this? This is where you create the actual technical blueprint, the plan for your code.
Okay, that makes sense conceptually, but it brings up a pretty obvious question, right? Where do you actually start? How do you go from a fuzzy idea to something concrete?
Now, here's the key thing to remember. This isn't a one-and-done straight line. It's a cycle. You start with a problem statement, you list out the features, and you write these little stories called use cases. Then you dig in to find your objects, maybe sketch out some class diagrams, and then you build in tests. But, and this is the crucial part, you don't just stop. You loop back again and again, refining your understanding with every single pass.
Okay, so I mentioned finding objects in that last step, and that's a huge piece of this. It's where the magic happens, really. How do you go from just a description of a problem to the actual building blocks of your code? How do we find these objects?
Well, one of the best ways to start is by writing what we call use cases. And don't let the name fool you, they're not complicated. They're basically just stories, simple scenarios that describe how a person, or maybe another system, interacts with your software to get a specific thing done.
Let's look at a really simple example. Say we're building an automated bird feeder. A use case might sound something like this. See, it's just a plain English story about what the system does. No jargon, just a clear description of behavior.
Now, hidden inside that simple story are the clues we need, and there's a really simple but powerful technique to find them called textual analysis. It's almost ridiculously easy. Just read through your use case and look for the nouns.
So if we look at our bird feeder story again, boom, the nouns just jump right out at you. Sensor, doors. Just like that, we found our first potential objects. These are the things in our problem that our software is probably going to have to deal with.
All right, so now we have our objects. We're done, right? Well, not quite. Finding them is just the first step. The real challenge, and where good design comes in, is making sure we design them well. This is what separates software that's a nightmare to maintain from software that's a joy to work with.
And to help us with that, there's a fundamental guideline in object-oriented design called the single responsibility principle. It sounds important, and it is, but the idea is super simple. Every object or class should have one job, just one reason to exist, and only one reason to ever change.
So let's go back to our bird feeder. A bad design might be to have one giant bird feeder class that does everything. It opens the doors, it identifies bird songs, it orders more seed, you get the idea. A good design, following the single responsibility principle, would break that up. You'd have a bird feeder class that only worries about the doors. And then you'd have a totally separate song identifier class. Each one has its own single job. This makes them way easier to understand, to test, and maybe even reuse in another project down the line.
And that really gets to the core of this whole thing. Great design is all about managing change. Object-oriented analysis and design isn't just a bunch of technical steps to follow, it's a way of thinking. It's about looking at your system and asking yourself, what's the one part of this that's most likely to change in the future? Once you identify that, you can kind of build a wall around it, encapsulate it, and that's what makes your system flexible.
So really, you can think of OOA&D as a toolkit. It gives you the tools you need to face that wicked problem we talked about at the beginning. It helps you build software that doesn't just work today, but can actually evolve tomorrow without falling apart.
So I'll leave you with this one question to think about. Look at whatever project you're working on right now. What's the one thing in it that's most likely to change? Just asking that question, that's the first step to building a better, more resilient design. Hey, if this breakdown was helpful for you, do us a favor and hit that like button, share it with a friend, and subscribe for more. It really helps us keep making content like this. Thanks so much for watching.